Happy doscember 2024. This is a companion piece to my video last year about creating real hardware scan lines on EGA games in DOS, but using only a VGA card and a standard definition television or analog 15 kHz monitor. This remains the closest way to experience what true EGA video looks like without actually having to own an EGA card and compatible monitor. As I noted last year, VGATV was the most reliable utility I found for forcing 15 kHz output in DOS. While VGATV's official documentation only notes several supported chipsets, I found that virtually every VGA card I threw at it could flip into 15 kHz mode and play standard mode 13H VGA titles quite well. This makes those VGA games almost look like console games when you play them. Interestingly, when playing EGA games, most of them would have massive underscan, meaning the picture was squished horizontally. My trusty ISA Trident 8900 was the only card with a chipset that was listed in the VGATV documentation, and it was the only card that actually played EGA games without underscanning. Although I haven't looked at the source code for VGATV, I have assumed that since specific chipsets were listed in the manual, that VGATV was actually written to tune the output of those chipsets more finely. As such, it's quite possible that why I was able to get good EGA on only a supported chipset was because VGATV had more control over the output of that card. I recently picked up an S3 Verge because S3 chipsets were also listed in the VGATV documentation. One funny thing I found was that if I actually supplied the S3 argument to VGATV, it became unstable, but if I let it auto-detect instead of supplying the argument, it worked just fine. My guess is there's likely a bug in the program that causes a different code path to be taken. Running the Verge with VGATV yielded a good picture for EGA games. So that has shown that so far of the two known supported VGA chipsets listed in the manual, both get EGA modes right when playing on a 15 kHz monitor. What is odd though is that when I would play 256 color VGA games, the color palette was absolutely messed up. This can be seen in this Doom clip here. In some ways it feels like as soon as I go into 15 kHz mode, the card is actually only capable of displaying 16 colors. While this isn't an issue for my purposes as I only want to play 16 color games, it is kind of an odd limitation. It also means that of the supported chipsets that I've tried, only the Trident is actually capable of displaying a proper picture in both EGA and VGA modes when running at 15 kHz. In general though, the Trident is a rather poor VGA card, simply because being an ISA card makes it rather slow in games. Now that I had two cards that actually could play EGA games at 15 kHz resolution without underscanning, I was ready to move on to my next challenge. Growing up, I was always impressed by the Tandy 1000, as it had better sound and graphics than other PC clones at the time. This enhanced capability was actually the byproduct of the Tandy 1000 itself being a PC Junior clone, but interestingly, none of the unique capabilities of the Tandy graphics or sound chips were ported to any other PC clones at the time, making it required to own a Tandy to actually get that capability. While Tandy is emulated in things like DOSBox, there are actually DOS emulators that allow your DOS machine to pretend it's a Tandy. The one I've been using lately is called Tandem. It has a Tandy BIOS and actually emulates Tandy sound through a Sound Blaster compatible. But the video output is 70 Hz line double VGA instead of the native 15 kHz rate of the Tandy. My goal, having played around with VGATV now, is just to see if I could get 15 kHz coming out of Tandem. Before we get into that part of it, I want to cover a few interesting usability quirks with Tandem. The first is that it only loads programs from a 360K formatted floppy disk, and this includes the Tandy DOS required to actually boot the machine. I eventually discovered that the GoTech floppy emulator allows its virtual disk to be formatted to 360K, and that takes away the need to have a real floppy drive, and it eases the overhead of moving games from a modern computer to your DOS machine, which is emulating a Tandy. This breakthrough, in my mind, has significantly lowered the barrier to using Tandem overall. To create the virtual disks on my GoTech, I used the disk imaging utility that came with Tandem. I even created a blank image so I can create a number of blank disks and copy game files onto those disks instead of actually having to find 360K game images. Finally, to ease my life even further, I made sure to image Tandy DOS to the default 000 slot on the GoTech, so I never even have to change any settings on the GoTech before loading Tandem. The second quirk is that I wanted to use DOS 7.1, which is the DOS that comes with Windows 98. This actually ended up being harder than I expected, and the challenge came down to hymem.sys. Tandem will not load if any memory managers are in place, but even after I commented out both EMM386 and hymem.sys from my config.sys file, it still complained that hymem was there. Eventually I found out that Windows 98 DOS will always load hymem, even if it's not explicitly stated in config.sys, and the only way to stop it from doing this is actually to set the DOS equals no auto directive right at the start of config.sys. Once I had a working Tandem, I was ready to see if it would actually work at 15 kHz mode using VGATV. Because VGATV can get a little funky if it's loaded after other things, I made sure to add it as the first line in my autoexec bat file so that it was there before anything else loaded. As I noted last year, your PC will always boot in 31 kHz mode, and then it only gets flipped to 15 kHz when you run VGATV. Because I had it in my autoexec bat, it was doing this on boot. But I found that I still wanted to watch the PC load until it got ready to flip over to VGATV, and so that it was simpler to have a switch in place that could switch between my normal VGA monitor and my 15 kHz monitor. That way when I booted it up, I could watch the boot sequence on my 31 kHz monitor until it went out of sync, and then I knew it was ready to flip over to my 15 kHz monitor and resume from there. I was actually shocked when I had this all set up and then loaded Tandem that it actually seemed to work at 15 kHz mode. As a real Tandy 1000 runs at 15 kHz, this was quite impressive to actually be playing an emulated Tandy at the exact same video resolution refresh rate as a real one. The only poor experience I felt was that some of the games seemed a little bit sluggish when I played them, but it's really hard to say whether that's just how they were on a real 4.77 MHz Tandy, or whether the overhead of the emulator was actually causing them to run worse. Hunting through Tandem, I couldn't find any other options that would allow me to improve performance, and so ultimately, I decided to look to other approaches for Tandy emulation in order to see if I could make those sluggish games perform a bit better. Over the years, a number of devices have been developed that can emulate or even recreate Tandy sound hardware on a IBM PC compatible. The catch with this hardware is that Tandy games won't actually detect your machine as a Tandy and thus won't work with Tandy sound. So you need to have some mechanism to override that in the game. Some games allow you to put a flag on the argument for launching the game, which will put it into Tandy sound mode, but others will actually require modification at a code level in order to output the Tandy sound. It should be noted that Tandy graphics adapters don't actually exist outside of real Tandy hardware, and so when you run a game on an IBM PC clone, it's either going to be using CGA, EGA, or VGA mode, and will never actually be displaying in Tandy mode. The crossover is that both EGA and Tandy are 16 color standards that run at 15 kilohertz, and so for the majority of games they should actually display identically. With that said, it is known that some Tandy games actually look different on a Tandy graphics adapter than they do on an EGA adapter. So to actually start to play Tandy games on a PC that has some form of Tandy sound card or emulated device installed in it, you effectively need three things. One, a game that can actually be modified or have a flag put into it that allows it to play in EGA or VGA mode but output Tandy sound. We actually need to buy that piece of hardware that either has real or emulated Tandy sound hardware on it. And we need to deal with the fact that there's actually some issues at an I/O port level whereby the Tandy sound card listens on an I/O port that really isn't available on non-Tandys. To solve the game issue, you can look at blogs like the Nerdly Pleasures one, where they talk about how to get Tandy sound out of some classic adventure games for DOS. There's also a whole section on oldschool.org where they've got all the Tandy patches needed to be able to force those games to play Tandy sound on non-Tandy machines. Solve problem 2 about getting Tandy hardware on a PC, you can go about it in a variety of ways. The oldest is actually to use a parallel port DAC, and then to run a piece of software called Temu, which actually emulates a Tandy sound card, and then pipes that through to the DAC. This is a pure software emulator though, so it will use a lot of CPU time, and I've definitely noticed sound glitches on games when using it. The other option is to buy hardware that either contains Tandy sound compatible chips or at least emulates it outside of the CPU. Problem 3 of the I/O ports that Tandy uses not really working on a PC is solved by a software redirection layer. The utilities that I looked at are TNDY and TNDY-BP. What TNDY boasts is actually compatibility with 386 and up CPUs, but it is known to cause some issues, and on my machine it would actually throw general protection faults. Tandy BP uses CPU hardware breakpoints, but requires a Pentium and up CPU. As I was running a Celeron CPU, Tandy BP worked great for me without any issues. So now, having collected the games I needed, the hardware that I needed, and setting up all that software redirection, I was ready for my last step of seeing if I could get all that to work with a 15 kHz video output. So once I had built my AutoExec BAT and config.sys for the setup just mentioned, the final step was actually to just add VGATV as the first line in the AutoExec BAT. Now I could try and run some of those games that were lagging a little bit in tandem to see if they worked better in this setup. And indeed they did. So the final question to ask is, why bother with Tandy sound at all? There was really only a small window where Tandy was the best sound option for a game. As soon as AdLib and MIDI came along, it really didn't make sense to play a game with Tandy sound if they also supported those better standards. But for those number of games where Tandy is the absolute best sound option available, it makes sense to want to chase that, especially on bare metal. On a personal level, my motivation has always been to play Sierra AGI games at their absolute best, and also some of those early LucasArts games such as Maniac Mansion. Being able to play these games with Tandy sound on a 15 kHz monitor is arguably the closest you'll get to that Tandy 1000 experience without actually owning one. And I wholeheartedly recommend anyone who's brave give this a shot, as both the audio and visual results are absolutely stunning. That brings this video to a close. Again, happy doscember everyone.